Hi everyone, this is my first tutorial video and I choose to start with Boolean algebra from Discrete Structures, and my name is Orhan Stamri. Let me write here. And my mail is okay. You can contact me with this email if you have any question. So let's start. I could write all these, some basic rules for you, but it will take so long time, and I choose to show you from the book. Okay, you see here x and y, and for understanding, let's start with only two things, x and y, and see some basic properties and theorems. And this is commutative rules, x, y, and it's like plus. Let me show you. You can say, for example, x and y and x and y. In some books it's showed like that, and in others it's showed like that. You can choose with which to work. But I will recommend you to work with this, because in most books it's used like that. So let's continue. Okay, this is x, y. Just remember this. Okay, just let me show you names. Disjunction. Okay, the name of this part will be disjunction, and this is like the multiplying. Okay, just don't look at this theorem, because I want to continue with basic rules. Okay, the second one is associative rules. Probably you remember this from your math classes from school. Okay, this is also very easy. Third one is a distributive rules. These two ones, the last two ones. Okay, this is also from our it's similar to rules from math class. And the last one, the Morgan rules, and this is this line for about over the x and y. It means negotiation, and just remember it. Okay, the Morgan, remember this. I will show it in examples when I solve some problems. And this all is elimination rules. Okay, now let me write all these last elimination rules in our paper. Okay, first one, and x, this is equal to x, this also is x. And sorry for my handwriting, because it's pretty hard to write with mouse. Then conjunction 1 is equal to 1, 1 is equal to x. Just remember, I'll sword all these rules, because you will need this when solving some problems. Negotiation comes to 1 and comes to 0. So then the last one, see, I forgot about the rule and started to write with plus, because beforehand I used to write with plus. Now I change it to this one. Okay, 0 is equal to x. Yeah, okay. And all this stuff is writing here. I write to show it's bigger. Okay, and the last rule, the name of this rule, as you see, it's elimination rules, and there is some extra rules, but I have not enough time to show all of them. But I will show one. This one is very helpful and beneficial for solving problems. Harder. Okay, and the last one is a, for example, and I can write either with a or with x. It doesn't matter, it's your choice. Okay, let's write with x, not to make your instance. Okay, x plus xy, x negation y is equal to x plus y, or no problem. So just remember this rule, because at the end of the video I will show proof of this rule. Make sure to make you sure that you understand everything. Okay, just now let's start with some problems, solving some problems. Okay, I think it will be easier to write with texting. Okay, first one, y equal to x b plus and w. Okay. Okay, it's no problem, and let's start to solve this problem. As we write now, a multiply l is itself is equal to a, so is equal to a b conjunction or plus w. So I started with the easiest one, and we finish here. Our answer is this one. So then okay. Alright, next one, a b c plus a b. Let's simplify this equation. No, we can take a b from brackets, and because it's same in both sides, c plus 1, and as we write for now we write this x and y, x plus or conjunction, we can write like that. Okay. 1. So as we write, this one is also equal to 1. Yes, it is equal to 1. So this will be is equal to a and b. So, and again, I am sorry for my handwriting. I hope it's understandable. So just let me delete. Okay. Third one. This is third one. I will show you the AB. Okay. X, Y. X, Y, Z, plus X plus X, Y, and let's write E. Okay, we said that Z multiply Z negotiation is equal to 0, because this makes 0, and everything multiplied with 0 makes 0, and this also will be 0. So we only left with this one, right? X plus X negotiation, yeah, and the X plus X negotiation we said is equal to 1 every time when we no, I forget every time this one. This and this makes every time to is equal to 1, and so is also is equal to yeah, only yeah. So I just forget no, let me delete everything here. And as I promised to solve one rule, the last rule, A plus A negotiation B is equal to A plus B. So let me write. Wait, no. Okay. A plus C and A plus B, and let's solve this problem. It's just multiplication and adding problems from math classes, and you know A multiple A is give us A, yes, then plus A multiple B plus A and plus B, yes. And for solving this, simplifying this equation, I take A from this, all of these three parts. Okay, let me write A1 plus B plus C and plus CB. Okay, as we know, 1 plus B makes 1, and again 1 plus C it also makes 1, so A multiple 1 gives us A, and this is A plus C B. Okay, we take this one and let's think that say is equal to A negotiation. It's our choice to think like that. So if we think so, we should write here A plus A negotiation plus A plus B will be equal to A plus A negotiation B. So as you see, we changed one thing and get the new rule. And the solving the left part, we see A plus A negotiation gives us 1. Okay, this is 1, and it will be equal to A plus A negotiation B. So finally we solved this problem. So I solved this problem, and I think everybody will understand what I wrote here, and I hope it will be helpful to understanding some simplification from Boolean algebra. And for harder version of this simplification I will show in next video. So see you.